Welcome back to our system design series. In this episode, we are going to talk about one of the most fundamental building blocks of scalable systems, which is load balancers. By the end of this video, you will know exactly what a load balancer is, why it is essential for large scale applications, and how it ensures your systems stay available and reliable all the time. So let's imagine that you have an e-commerce system, or like an e-commerce store, and let's say that we have a lot of customers and clients. Okay, and these clients sends a request to our server, and let's say that your e-commerce is getting too popular and getting too successful, so you have even more clients that sending more requests to the server, and our server right now reaches its limits. So it's time to scale. So how we can scale? If we want to scale our server to be able to serve all the clients, we could do one of two things. We could add more resources. So basically, we can add more RAM, more CPU, etc. But there are some problem comes with that we have a physical limit. We cannot add RAM endlessly. There are a physical limit to which um the scaling will be and the adding of resources will be. And the other thing, this is quite expensive. And lastly, we have what we can call a single point of failure. So if we have only one server, so if this server went down, our application is lost. So the other solution is to add more machine. So instead of have one server that serve all the clients, we can have server 1, server 2, and server 3. Let's put all of them here. And let's call it server 2 and server 3. Okay. And right now the clients will send clients will try to send the request to each server, but how the clients can send the request to the server? We need something in between. We need something in between that will distribute all the incoming requests to the servers, so we make sure that each server get the same requests as the others. Also depends on its weight as well, and also we make sure that we lose no cache. And this is where sorry, go back. And this is where the load balancing come into place. LB, let's call it LB, and let's give it a different red color. And make this a red one. So again, imagine you are running an online store and suddenly there is a huge influx of users because of scale. You want to make sure that all these users can browse and buy without crashing your server, right? So this is where load balancers come in. Load balancer will distribute incoming requests across multiple servers, ensuring that no single server becomes overwhelmed. So what will happen is that the client will send a request. Okay, why is that big? Can I work with this? Why it's really big? I don't know. Let's work with that. So when client, it will distribute all the incoming requests to, let's make it different colors so it will be easier for you guys to see what's going on. And lastly, I guess I could make this one. Yeah, this will be better. And yeah, let's make this like greenish or something like that. Okay, so as we said before, a load balancer is a component that helps distribute traffic across multiple servers Think of it think of it like a traffic cop directing cars on a busy road to different lanes to prevent any one lane from getting too crowded. In system design, load balancers ensure that incoming requests, whether they are user clicks, API calls, or data processing tasks, are spread evenly across the servers handling those requests. So this is not only helps with balancing the load but also ensures reliability. If one server fails, the load balancer can reroute traffic to other healthy servers. So if server one just went down, the traffic will be rerouted of this client because this client is responsible to connect with this one. The traffic will be connected, for example, with server two, for instance. So this is how it's improved the availability, reliability, and performance of the system, and also overall the scalability. Um, Common examples of load balancers, including Nginx and HProxy, you can use like, and there is also cloud-based solution like AWS Elastic Load Balancer, which is ELB. And these tools help manage traffic effectively and efficiency, ensuring the availability and performance of your system. So let's try to answer another question, which will be when and why to use the load balancer. So when should we use a load balancer? The short answer, whenever your application grows beyond the capacity of a single server. As user demand increases, a single server might struggle to handle all incoming requests, causing slowdowns or even downtime. A load balancer helps you scale horizontally, meaning you can add more servers to share the load. And the other thing, also load balancers also vital for fault tolerance. If one server crashes, the load balancer will quickly divert traffic to other servers, ensuring minimal impact on the user experience. This redundancy makes your application more resilient to failures, improving overall uptime and reliability. There are multiple real-time examples like Netflix, with millions of people are streaming shows at the same time. Netflix uses load balancers to distribute traffic across their server clusters to make sure you get smooth, buffer-free viewing experience. Um, so, in system design, load balancers are often placed at front of the server clusters, acting as gatekeepers for all incoming requests. They help create scalable and fault tolerance architecture that can handle growth and unexpected traffic surges. So, understanding how to use load balancers in is quite essential for designing systems that can grow while maintaining reliability. It's a key skill for developers aiming to build robust and scalable applications. So, to recap, load balancers are like traffic controllers for servers, helping distribute requests evenly to maintain performance and availability. We talked about the types of load balancers, when to use them, and how they play a critical role in in scaling and fault tolerance. We didn't talk about the algorithms that load balancer is using to handle the distribution of requests, but we will talk about that in a different series because I am thinking about creating a series only for load balancers to get in-depth overview of how they are working. So that's it for this video, and see you in the future.